Hello everyone, the problem that we're looking at today is the 2019 US Open contest silver problem 1 of left out. The problem is very straightforward. You have a grid and you're trying to make all the cows facing the same direction by turning only rows and columns, entire rows and entire columns, and you're trying to find the one cow that's going to be left out when every single other cow is facing any direction. So you can pause the video for a second and think about it yourself. Okay. So this is one of those very classic silver problems where you just have to make some notice, otherwise it's absolutely impossible to solve. The most important notice for this problem, I would say, is the fact that you have to make some of the cows work, which might be a little bit vague at first, but basically what I'm saying is since only one cow doesn't work, most of the cows does work. And also a very obvious notice that I didn't mention but might be more fundamental is the fact that it doesn't really matter whether they're facing left or right, because if they're all facing left, you can just change every column and now they're all facing right. If they're all facing right, change every column or every row, they're all facing left. So it doesn't actually matter which direction they all face. We just know that one is left out. So most of them have to work. Only one doesn't work. So we can basically just fixate any row or any column, and we just say that this row or column have to work. We make it all work, and then check what's the one left out when this entire row or this entire column that we specifically assigned now works. So let's think about how do we do that. So the most special row and column is obviously just row and column 1, and that's exactly what I did. So let's see my notice here. Okay. So this is my notice. The order change doesn't matter, but that doesn't actually affect the answer. The actual real notices are, first of all, notice the first column and first row have to be right because, well, at most one is not right. So this entire column, entire row, most of them has to be right. So basically all we have to do is to flip every single column so we can get the first row to be right, and then flip every single row so we can get the first column to be right. And after we've done that, notice that we can't do anything anymore because the first column and first row are both completely correct now, and anything we do is going to mess up this first column and first row. I mean, there's no way for us to get it back. So with that observation in mind, it's basically just casework after flipping all the rows and columns to get the first one to work. So this is actually a very, very, I would say, no brain trick, but sometimes people just can't think outside the box of thinking this strategy, is the fact that there's no breakthrough point, so let's create one. And the breakthrough point we created is the first column or the first row. So the process is then, also I have to go through the casework, obviously. So if all of them are 0 already, which is what we want, assuming, because if they're 1, we can just turn all of them to 0. If they're all 0 already, then obviously we can just print no mac house. And if there are 1 being reversed, then we just flip the first. Oh wait, if they're all 1, so if they're all reversed, we can just flip the first row and first column, and the top left is our answer because only 1 is going to be reversed twice. Every single other cow in the first row and first column is only going to be reversed once, but 1 is reversed twice. If all cow but 1 is good, obviously that's the answer. If the entire row or column that's not the first row or column, so if it's a middle row / middle column, it's reversed, but the head is not, then this head cow is our answer. It's a very good problem. Also, a very small bonus notice is the fact that only 2x2 rectangles doesn't work. Any bigger rectangle can be turned into a 2x2 rectangle that doesn't work. So my code is simple. Flip the columns with this, flip the rows with this, and we check every row or column. If it's reversed, we flip it, and then we start caseworking. This casework is so lengthy, but honestly pretty straightforward. That's the first case in which we're done, no such cow, -1. If there is such cow, but it's top left, then we just output top left, and then we check every row or column to see if it's the head of this row or column that is wrong. So hopefully that will give you an idea of how to solve this problem. Honestly, really good for 2019, but also considering that it's US Open, I would say is moderate difficulty. And it's pretty good thinking, and you just have to think outside the box and just create your own breakthrough points because you know that most of them is going to work. Thank you for watching, and I'll see you tomorrow. Okay, so the grind report is actually going to be pretty hilarious today because I did one problem, but I got a credit of 4 on Logu because there's just 4 of the exact same problems. And basically just copy and pasted the code for 4 problems, and now I have 4 blue level problems on Logu, which is like pretty hard problems. So the one I did is job completion from December gold of last December, and honestly, I would say it's a really standard problem. Is I think in English would be called revocable greedy or retrievable greedy or something. Basically, a greedy, except you can reverse the options that you made earlier if you now see better options. Pretty straightforward. The code is really simple, and the problem just can't be simple. Like when I first saw the problem, I was like, "Isn't that a template for like some kind of a bronze level problem?" But it turns out it isn't, and but it's obviously also expected that there's 3 other problems that have basically the exact same solution. I just copy and pasted the code and spent maybe 30 more minutes to modify it slightly to fit the other 3 problems, mostly just because I had to output cases. And also, one of the problems, legitimately, the problem statement was wrong. And it took me like 10 minutes to debug for that. Anyways, yeah. So that's it for the grind report. Still didn't actually grind because the code was really simple, as you can see, like 50 rows at most. So, thanks for watching. See you tomorrow.